الكيميائية physical and chemical properties of alkyl halide. كذلك تناولنا ال preparation of alkyl halide and some reactions that these compound can undergo. In this lecture we are going to deal with the mechanism, and in this next lecture, which is like handout 3, we are going to continue with mechanism and compare the difference between these like mechanisms that explain the chemical reaction of alkyl halide reactions. كما تشوفون بالسلايد الأول حطيت لكم مركبين دوائيات التي تحتوي على like carbon halogen, which is like considered to be alkyl halide. First one on your left hand, we call it fluticin. Is a drug that you use mostly for nasal septum. In 2017 was the 15th most common drug that used in USA, with more than 20 million prescription. Like the sale for this compound was like achieved 4.7 billion per year in 2017. So it's so important. The second compound that I bought, which has also the fluorine, like the fluorine halogen, called stigleptin or stigleptin, used for like a diabetes type 2, like for a year like the 2017, or like not sure about which year, achieved like 3.6 billion per year. So they are really good drug to use. In this slide, as we said, like we do have six topics to cover. The first is the alkyl halide, and we divided the lecture of alkyl halide to 3. Today we are dealing with the second one. And again, if anyone want to expand his knowledge, want to like have more information, these kind of reference that the best to go back to read about our topics. And also my lecture is come out from these references. So as we spoke last week about nucleophilic substitution reaction of alkyl halide, we said in substitution is replacement of one group, which is here the halogen, by another. A nucleophile, a species with unshared lone pair, reacted with an alkyl halide by replacing the halogen substitution. إذا لاحظنا بالبوكس nucleophile هو أي ذرة تحتوي على مزدوج إلكتروني قابل للمشاركة، في حين السبستريت هنا اللي هو الألكيل هالايد the bond between the carbon and the leaving group breaks. احنا مثل ما قلنا بأنه الآثرة بين الكربون والهالوجين is polar بسبب اختلاف البولاريزيشن، اختلاف الإلكترونيجاتيفيتي between the halogen and the carbon. الهالوجينات has high electronegativity، ولهذا راح تسحب الكثافة الإلكترونية باتجاهها، وراح تحتوي الشحنة partial positive، في حين الكربون راح تحتوي الشحنة الهالوجين راح تحتوي على شحنة partial negative، في حين الكربون راح تحتوي على شحنة partial positive، لأن راح يكون بها نقص إلكتروني، في حين الهالوجين اللي هو الإلكترونيجاتيفيتي مالته عالية راح يصير بها كثافة إلكترونية عالية. فراح يتكون عندي مركب جديد اللي هو R nucleophile. الآثار اللي تكونت بينها، الآثار الجديدة اللي تكونت هي عبارة عن مزدوج إلكتروني قادم من النيوكليوفايل، في حين الآثار اللي كانت في الألكيل هالايد بين الR والX أخذت من قبل الهالوجين، وظهر لنا بشكل أيوني X minus. ولهذا leaving group اللي هو الهالوجين gains the lone pair that originally bonded it in the substrate. المزدوج الإلكتروني اللي كان فيه الأساس هو الآصرة بين الهالوجين والكربون. زين، الميكانيزم اللي تشرح لنا شلون صارت التفاعلات التعويضية nucleophilic substitution mechanism. There are two different mechanisms are possible here. Either the leaving group, which is the X, goes first and the nucleophile comes later, or the two events happen at the same time. هسه أما عندنا الهالوجين هو يغادر قبل، بعدين نيوكليوفيل يتحد مع الآر جروب، أو لا بنفس الوقت نيوكليوفيل يتحد مع الآر وبنفس الوقت نيوكليوفيل يتحد مع الآر وبنفس الوقت الليفينج جروب تغادر الآر. The first one, these possible, we called it the SN1 mechanism. الاحتمالية الثانية للميكانيزم نصيح لها بال SN2 mechanism. راح نجيب التفصيل عن مود نفتهم شنو معنى ال SN1 وشنو معنى ال SN2. Mechanism for the SN2 reaction, what we are mean by the SN2. SN2 means substitution nucleophilic bimolecular. Bimolecular يعني معناها جزيئتين. We mean that two species involved in the step that control the rate of the reaction. الخطوة اللي تحدد سرعة التفاعل. إذا لاحظنا بالمركب بالبوكس الأسفل التفاعل عندك هيدروكسيد اللي هو nucleophile has like a lone pair which is happy to share with others, and we do have the alkyl halide which is the chloromethane. Under this condition, which is 60 degree or 60 Celsius in water as a solvent, we will get a methanol, our product, the target, and chloride as a leaving group. In this reaction, as we see, there is substitution which means is replacing the chlorine with hydroxide. As we see, like the product has like hydroxy group which become alcohol, and there is two substrate that involve in the step that control the rate of the reaction, which is the hydroxy group plus the substrate. So that's why we call this kind of mechanism substitution nucleophilic bimolecular. يعني عندي جزيئتين مشاركة في هذه الميكانيزم. The hydroxide ion is a good nucleophile. As we said, it has like a unshared lone pair which is happy to share, and the carbon atom is electrophilic. بها نقص إلكتروني. Because if you look to the box, we said it's a partially positive. Why? Because like the chlorine has, or like any halogen has electronegativity عالية. هاي الإلكترونيجاتيفيتي العالية تمكن الهالوجين بسحب الكثافة الإلكترونية باتجاهها, so is withdrawing the electron density toward it. So we لاحظ الهالوجينات راح تحتوي على شحنة جزئية سالبة في حين الكربون راح يحتوي على شحنة جزئية موجبة, ولهذا we call the carbon here is electrophilic. عنده نقص إلكتروني, يعني بحاجة إلى كثافة إلكترونية. تمام. The nucleophilic hydroxide is attracted to the electrophilic carbon, لأن مثل ما قلنا هذا يحتوي على إلكترونات في حين الكربون هو في حالة نقص. So there is like electrostatic charge between them which attract through donation of two electrons. إذا لاحظنا بالبوكس راح نلاحظ الهيدروكسي group which is in red color will like attack the carbon that has like a partial positive charge to form like a not fully bond. As you see, there is like transition state in the middle. So this transition state, if we can see, there is a bond between the hydroxy group and the carbon, which is not fully, so that's why it's like a dot, and it's red because these, like, as we know, like the bond is consisted from like a lone pair, 2 electrons, and these 2 electrons, both of them, they are coming from the hydroxy group. And if we look to the, like, the second side is with the chlorine, is a not a fully bond as well, is a partially formed bond between the carbon and like the chloride, and it has like green color, which means these 2 electrons will be belong to the chlorine. This transition state will convert straight away to the product, whereas like alcohol is made, and we can see there is a new bond between carbon and hydroxide group, which has like the red color. Again, the red color means these 2 electrons come from the hydroxide, which is red. في حين الكلورين غادر مع أخذ المزدوج الإلكتروني اللي كان يكون الآثرة. هنا إذا رجعنا للحالة transition state ونقرأ جواها راح نقول in the transition state a bond between oxygen and carbon is partially formed and the bond between carbon and chlorine is partially broken. هسه هنا النقطة الأخرى, the configuration of the carbon atom began to invert, and إذا لاحظنا بالproduct the configuration of the carbon has inverted. إذا قارنا بين السبستريت اللي هي المادة المتفاعلة والبرودكت راح نشوف صاير عندي روتيشن، استدارة للمركب. طبعا هذا راح نشرحه بشكل مفصل بمحاضرة الستيريوكيمستري، بس اللي أريده تفتهمه الآن بأنه الهيدروكسي جروب سوى اتاكينج للكربون من الجهة المعاكسة لوجود الكلورين، ولهذا formed a bond in the opposite side of like the bond that was between the carbon and the chlorine. راح نسولفها بالتفصيل إن شاء الله في محاضرة الستيريوكيمستري. Functional group transformation of alkyl halide. Alkyl halide can convert into a wide variety of organic compound مثل ما سولفنا بال preparation or as well like the reaction of alkyl halide. Alkyl halide can undergo to many other compounds. We spoke about the functional group in the first lecture in the lab. We said this functional group is the most like reactive side in the molecule. Here the alkyl halide, the most reactive is carbon halogen, and carbon halogen can be converted to a different functional group. And if we look to this diagram, alkyl halide in the middle, if I reacted with like a nucleophile, I will get a different like functional group, different like kind of organic compound. So for example, if I reacted alkyl halide with hydroxy group, I will get like alcohol, ROH, في حين, which is the above in the diagram, that فعلت alkyl halide with like RO minus, like for example come from methanol, methoxy, اللي هي CH3O minus. If reacted methoxy group with RX, I will get the ether, or with HS I will get the thiols compound or sulfide and so on, or like with the ester or alkyne or azide. ولهذا بالتفاعلات بالإكزام طريقة الامتحان راح يجيكم مثلا حضر لي، يعني قلت لكم بالمحاضرة البارحة بأنه يجيك مثلا بالامتحان أقول لك حضر لي داي إثيل إيثر اللي هو CH3 CH2 أكسجين CH2 CH3. فأنت راح تشوف ال R جروب، واحدة من ال R جروب راح تجيكم من الألكيل هالايد، في حين ال R جروب الثانية راح تجي من النيوكليوفايل. تمام؟ وهكذا. And this is the main functional group or main reaction that alkyl halide can undergo. There are so many others. I gave you example like at the bottom of the slide. I said what is the product that can be obtained from the reaction of triphenylphosphine. Like there is two dots, which means it is a lone pair, is a nucleophile, and if it's reacted with an alkyl halide, what kind of product you can get from this reaction. So the second mechanism is the SN1 reaction mechanism. What we mean by SN1 mechanism, S referring to substitution, and nucleophilic, and when referring to unimolecular. So if you look to this example, where is tertibutyl chloride reacted with hydroxy group in a mixture of solvent, here are the acetone and H2O to give us alcohol plus like ion chlorine, and the hydroxide ion in this kind of mechanism do not participate in the transition state of the step that control the rate of the reaction, and only the tertibutyl chloride. What we mean by the rate of the reaction? The rate of the reaction is the speed at which a chemical reaction takes place. So to initiate this reaction, only tertibutyl chloride will start in the first step, and the hydroxy ion will come later. We will see what we mean by that in the next step, in the next slide. So if we look to the first step in this mechanism, we will see there is only unimolecular, there is only one molecule to start with. So like the chlorine, the halogen will leave, taking the lone pair that form the bond between the halogen, the chlorine here, and the carbon. I draw it in the green, so you will, in green color, so you will see that these electrons are moving out with the chlorine to form a new species, which we called it carbocation intermediate. Carbocation is really reactive and stable, and the carbon here has like a positive charge because is lost like a 2 electrons and need to have 2 instead. As we know, like carbon, it's stable with 8 electrons in the like outer level of energy, so it has only now 6 and need to have 2 to be stable. So the next step, we will see water. The lone pair in water will attack the carbon cation to form intermediate. We called it tertibutyloxonium ion, or you can call it like a protonated alcohol, up to you. And the third step will be like attacking from another water molecule and to remove the hydrogen, the extra hydrogen, to give us alcohol plus hydronium ion, which is H3O mujib. And as you see, there is 2 species here as side product, which is the chlorine ion and H3O plus, and these can react between each other to give us like H2O plus HCl. So the mechanism of SN1 reaction is involved with 3 steps. The first steps is where like the halogen leaving, taking the lone pair, form a new species which is very reactive and unstable, and these like intermediate can go straight away to the next level of the reaction, which is so fast, by reacting with another molecule here, which is the water, to form tertibutyloxonium ion, and this can go again to the like a third step, which is removing the extra proton by another molecule of water to give us the desired alcohol plus hydronium ion. The hydronium ion can react with the chlorine ion to give us like HCl plus the H2. The water, which is the solvent here, is like stabilize the ions by solvation through like coordination and hydrogen bonding. We said the first step is the slow step because to form the carbon cation you need a lot of like free energy for activation to make chlorine leave the alkyl group. So it's the lowest is endothermic. If we look to this diagram, we will see there is a lot of energy needed to this step to be happened. So it's endothermic, need a lot of like free energy for activation to make the chlorine taking the lone pair and leaving. في حين if we compare it with the second step is needed, like if you look in the middle, the peak is needed less energy to transfer it and to form like the butoxonium ion in the second step, and this butoxonium ion is much faster can go to the desired product in the third step to form tert-butyl alcohol. So we will see like the product always end up with less energy, more stable compound. So if we look to the stability of carbon cation, if we look in this books, there is like carbon cation depend on the R attached to the carbon that has the positive charge. We can call it a tertiary when there are three alkyl group attached to the carbon that has the positive charge, and we called it a secondary when there are two, and a primary when there is only one R group. Is similar to alkyl group when we said there is primary, secondary, tertiary type is depend on the R that attached to the carbon. Here as well is depend on the R that attached to the carbon that has a positive charge. We called it tertiary or secondary or primary, or like only methyl group when there is no R group. And depend on how many are attached to this carbon is give it more stability. For example, if you look to this in this book, you will see tertiary is more stable than secondary, and the secondary much stable than methyl group without R group. So the question here is why R group is stabilizing the carbon cation. So this is for you guys to think about that. So in the next handout, which is the third and final part of the lecture 1, we are going to study the factor affecting on the rate of SN1 and SN2 reaction. Some conditions that we use in the reaction would prefer the SN1, and other reaction would another like condition reaction would prefer the SN2. So it depends on the condition that we are using and depend on the substrate, and we are gonna go in details about that. Then we are gonna move to study the another two important mechanism for elimination reaction. We said elimination reaction هو تفاعلات الحذف, which we will go with E1 and E2. We call them E1, which elimination 1 and elimination 2. Then we are going to do comparison between all four mechanisms of alkyl halide reactions. And it is worthy to notice here that we didn't speak about like the stereochemistry, the outcome of the stereochemistry of this mechanism. So we are going to cover these kind of topics in the next slide, where we are going to speak about the stereochemistry, which is the part 2 in the